Start by exploring what bearings are and why they are so essential in rotating equipment. Bearings are machine parts that allow other components, like shafts, to rotate or slide smoothly. They play a crucial role in supporting shafts, keeping them in the correct position and reducing friction between moving parts. There are two main types of friction to consider: rolling friction, which occurs when one body rolls over another, and sliding friction, which happens when one body slides over another. Bearings are specifically designed to minimize these frictions, making machinery more efficient and durable. Lubrication is another key aspect, as it forms a thin film between surfaces, reducing direct contact and wear. By understanding these fundamentals, technicians can ensure equipment operates smoothly and lasts longer. Now let's look at how lubrication works in practice. Bearings come in various types, each designed for specific loads and applications. The main classifications are sliding surface bearings, also known as plain bearings, and rolling element bearings, often called anti-friction bearings. Sliding surface bearings provide a smooth surface for shafts to slide over, typically using materials like babbitt or bronze. These are further divided into radial bearings, which handle forces perpendicular to the shaft, and thrust bearings, which manage forces along the shaft's axis. Rolling element bearings, on the other hand, use balls or rollers to minimize friction and can support both radial and axial loads depending on their design. Understanding the differences helps technicians select the right bearing for each application, ensuring reliability and efficiency. Next, we'll examine how lubrication and maintenance keep these bearings in top condition. Proper lubrication is vital for bearing performance and longevity. Lubricants reduce friction, minimize wear, dampen shocks, cool moving parts, prevent corrosion, and seal out contaminants. There are different lubrication methods, such as splash, ring oilers, and forced circulation systems. Each method ensures the lubricant reaches critical areas, forming a protective film between surfaces. Maintenance involves regular inspection for symptoms like abnormal temperature, vibration, or noise, which can indicate bearing failure. Common causes of failure include metal fatigue, dirt, improper lubrication, misalignment, and overloading. Technicians should follow best practices for installation, ensure correct clearances, and use the right lubricants. By staying vigilant and maintaining bearings properly, equipment downtime is minimized, and operational efficiency is maximized. Let's wrap up with a look at troubleshooting and storage tips. Effective troubleshooting starts with recognizing early warning signs such as increased noise, heat, or vibration. Technicians should listen for abnormal sounds, feel for unusual temperatures, and visually inspect for leaks or contamination. When issues are detected, it's important to identify the root cause, whether it's improper installation, inadequate lubrication, or environmental factors like dirt and moisture. Using the correct tools and following manufacturer guidelines for installation and removal can prevent many common problems. Additionally, storing lubricants in clean, accessible areas and maintaining high standards of cleanliness helps ensure that only uncontaminated lubricants are used. By applying these best practices, mechanical technicians can extend the life of bearings, reduce downtime, and keep rotating equipment running smoothly.